Tamara invests $5,000 in an account that pays 4% annual interest. How much money will there be in the account after 3 years if the interest compounds annually, semi-annually, quarterly, or monthly? So the compounding means, all right, if it's annually, she gets 4% of the $5,000 after 1 year. And then after the second year, she gets 4% of the new amount of money. And then after the third year, she gets 4% of that amount of money added to the account. Compounding monthly means that process happens every month, but you're getting 1/12 of the amount of interest per month. So it compounds faster. The formula basically works this way. So when it compounds annually, you take the percentage divided by 1, which really means it's like it was in the last lesson. And then you multiply the exponent by 1. So really nothing is different. It's just the b value is the b value, and then the exponent is the amount of years. Semi-annually means twice a year. So instead of dividing by 1, we're dividing by 2, and instead of multiplying the exponent by 1, we're multiplying it by 2. So the only thing different in the formula is those numbers in red. Semi-annual means twice a year, quarterly means 4 times a year, and monthly means 12 times a year. You can see the effect on the money. It's marginal, but it is real. There is a different amount of money that you end up with after 3 years. If you compound semi-annually, it's about $6.50 difference. You get another $3.50 by doing quarterly, and you get another 2 and change if you do it monthly. All right, so the numbers are different. So here in the try it question, another amount of money to start. Annual interest rate is 3%. We're going to compound monthly. So what is the value in the account after 10 years, and what is the value in the account after 100 years? So we're going to do that calculation twice. So why don't you pause it, give it a try, and then come back. All right, let's take a look. So the first one I set up, the amount of money after 3 years is equal to $3,000 that you started with times 1 plus the annual interest rate 0.03 as a decimal divided by 12 since it's monthly, compounding monthly, raised to the power of 10 for the number of years times 12 because it's monthly again. All right, when you evaluate that, you end up, and we're rounding to the nearest cent for any dollar and cents question. $4,000.48, $4,048.06. When I set it up for 100 years, the only thing that's different is instead of 10 years, it's 100 years. Everything else is the same. All right. Calculate that, and $60,000, $60,031.45. Right. So it's way different. The money just sat there, earned interest, and turned into that after 100 years. All right, let's look at example 3.